Okay, friends and students, today I'll discuss electric lines of force, and it is also very important article in electrostatics, and a lot of questions are being asked in NEET, JEE, and the advanced problem is there. So, electric lines of force. Electric lines of force. So, obviously, it is an imaginary line is there, but due to electric lines of force, whenever it is drawn at any point, a lot of information we can get. So first let me write its definition, because so many students and some other persons are giving very wrong definition of electric lines of force. So first give attention on this definition, and then further I'll discuss. So its definition is there. So definition, so it is the path traced by unit positive charge in electric field starting from rest. So starting from rest is very important. Starting from rest, right? See, it has a great value, the statement of this. So when a particle starts from rest, then the particle must move in the direction of force, right? So in which direction the force will be applied, the same direction the particle will move, right? So if you have only isolated positive charges there, so isolated positive charge. So if you have isolated positive charge, so it's very simple. It means what? At this point you are keeping unit positive charge should be repelled. So electric lines of force will be like this. So isolated positive charge, then isolated negative charges. See, it is the force, or it is the path traced by unit positive charge. So if you have negative charge at this point, then it will be attracted. Then it will be attracted. And if you have isolated positive and negative charges, so plus q and minus q, so then we can draw electric lines of force like this, and so on and so forth. But see, mainly I have to know first the properties of electric lines of forces, right? So properties of electric lines of force. So properties of electric lines of force. So it always emanates from positive charge and converges to negative charge. Okay, so that is, if it is positive charge, it should emanates outside, and if it is negative charge, it is towards, or if it is both, then always, right? So it can never be closed. It can never be closed due to, so never be closed in electrostatics. In electrostatics. So suppose if plus q and minus q, if you are drawing like this, and suppose somebody write this, right? So this is wrong. It can never be closed. Then the tangent drawn at any point on it gives the resultant electric field intensity at that point. So resultant, right? So it gives you not electric field intensity, it gives you resultant electric field intensity, right? So it gives you resultant electric field intensity at that point is there. So how one can draw that? You can draw so tangent, so it gives the tangent drawn at any point is. So suppose you have this is the electric lines of force. So at this point you draw the tangent. This gives you direction of electric field. So this gives you E. At this point, if you want to draw the tangent, this gives you electric field intensity at that point. Then 2 or more than 2 electric lines of force can never intersect. So this is there. So this is wrong. The reason is at this point 2 tangents can be drawn. So one tangent is this and one tangent is this. So at the same point you cannot have more than one resultant electric field intensity, right? So it can never, right? Then the density of electric lines of force, that is number of lines per unit area. So the density of electric lines of force gives the intensity of electric lines of force at that point. That is the density of electric lines of force is directly proportional to the magnitude of electric field intensity at that point. At that point. So I'm drawing this point. So the density is the right, the number of lines per unit area. So number of lines per unit area. So suppose you're writing this. So here density is constant. So E is constant is the right. So uniform field is the. This is uniform field. But see, if I'm writing so at this point E1, at this point E2, then E2 is greater than E1 because density at this point is the same. But keep into mind one thing, note the density of electric lines of force does not change in the perpendicular direction of electric field intensity. Electric field intensity. So see, if somebody writes like that, if somebody draw this way, then this is wrong. It is not possible because density changes in the norm perpendicular to the direction of field. So this is the direction of field is there. So this is not possible. And one more thing. The number of electric lines of force converging or diverging is directly proportional to the magnitude of the charge. Magnitude of the charge. So the number of electric lines of force converging or diverging, right? It simply depends on its magnitude. So now, whenever we have different magnitudes are there, means suppose if you want to draw plus 2q and minus q. So this is there. Now few lines will be in here. And suppose this is plus q minus 2q. So this line is there. and few lines will be like this. So this is, that is, if when the magnitude of charges are not equal, then be careful, we are using this properties. One note, first, electric lines of force is always perpendicular to the surface of a conductor. And second, electric lines of force can never pass through a conductor. So this is all about electric lines of force. For further, you can join our class and then come to know about these different type of problems are there. Okay, thank you.